Nope, this isn't clickbait. I'm currently looking at the country selection screen inside of EU4, where chess has been added. This monumental project occurred during the EU4 Marathon, where I had the liberty of partaking in a team with Sol, Zrome, yes that's Zrome from Zrome AI, and Scrubbot to deliver this project during the limited time of the marathon in question. Not only is the ability to play against other players in multiplayer an option, it is also possible to play against the integrated chess engine AI, as well as, within the game itself, change the theme of our pieces. Ooh, Austria flavoured, or even Byzantium. We know you all love Byzantium. But yes, to be clear, this includes fully within EU4, no outside communication, a purely EU4 integrated chess engine. Let's give it a game. You can go ahead and begin by selecting a square where you have a piece, select the piece in question, and moving it to the appropriate square. And as you can see, black will respond. And yep, we can do this to play a game. It's chess. Not sure what else to say. It's chess. I'm playing chess inside of EU4 right now. In terms of the magic of running this all well within the domain of EU4 itself, well, Sol, the team lead, has gone through the liberty of setting up a presentation for our enjoyment, going to detail about how this incredible feat was actually achieved, and we'll get into that, but I will begin with a disclaimer. Namely, that my contribution to the team here was I made the chessboard, and I did a lot of playtesting for it and found a lot of issues and got them brought to the attention. I thought I was being very annoying actually because I found a lot of bugs, but you know, that's my contribution. And while I don't believe that's enough for me to take credit saying that I put chess inside of E4, Sol insisted upon me using I added chess to E4 as the title, as well, let's be honest, that's a good YouTube title. But I will have to formally make this disclaimer here for my own peace of mind. A lot of the magic for the code involved for chess is made by him, and by a lot I do mean the vast majority of. And before we do finally begin his presentation with him on that, let's just get the usual quick stuff out of the way. A like and would be appreciated, and a subscription would be amazing. Without further ado, I'll let Sol take it from here.
Hello everyone, I'm Saul. I am a longtime EU4 modder and also a programmer and a historian. I have made several other EU4 mods in the past before EU4 Chess, like EU4 Minesweeper, EU4 Blackjack, and EU4 Cookie Clicker. Yes, there's definitely a theme going on here. But EU4 Chess itself, my latest mod, was made, as I'm sure Lemon mentioned, as a part of the Season 4 Modathon, a modding competition. And in this, it is a team effort. My particular portion of this, beyond being the team lead, was mostly on the code side, and that is, for the most part, what this video is going to explain. How on earth it is possible to put chess into the game Europa Universalis 4. So let's start out, and on this slide you can see a particular example of the game in play. So my mod, as you would expect from the name, adds chess to EU4. It is intended to be a multiplayer experience playing against other players. However, I did also add a chess engine into EU4, largely because I could, bragging rights and all that. But one of the other features that this mod has is piece themes, and as you can see on the image on the right, you can see a Byzantine chess player playing against a Persian chess player, and that's just a way to make the game a little bit more themed and a little bit more fun for the integration into the EU4 experience. Beyond that, it's just chess. You know chess. You've probably played chess before. It's good stuff. So the mod can be broadly divided into 4 components for our analysis. The first two, the chess code and the chess engine, were largely my part in this mod. The following two, 3D models and art, and then the province UI, were largely handled by other teammates, and so I will be covering those quickly, but I will not be able to do as in-depth of an analysis as I will over the first 2 sections, which are going to be the meat of this presentation. Starting out with the chess code, we need to go over some core concepts related to chess, and the following few slides will be covering that. So starting out, how do we implement a turn-based game in EU4? There's a lot that goes on underneath a turn-based game. We need to figure out who the players are, what specific countries they belong to. We need to figure out whose turn it is. We need to figure out which player is white and which player is black, and then we also need to handle the event of a player making a move and then switching it to the next player. All of this is not particularly trivial because EU4 doesn't really intend to have a turn-based game developed inside of it as a mod. Another important question is how we store pieces and how we store the game board where pieces are arrayed. This is very important because without a mechanism to store pieces, not only can we not cannot display a game board, but we also can't do any processing such as the AI looking at a particular game board and figuring out what the best possible move there is. The final concept is the idea of a pseudo-legal move, and this is a chess concept, not really an EU4 related concept. So the idea here is that a legal move is a move that you can play that then does not also leave you in check. The difference between a legal and a pseudo-legal move is that a pseudo-legal move can accept check in the resulting position. And this is a very important distinction from a programmatic standpoint that will come into play later. And so it is important that we go over that right now. But the code itself can be, again, divided into 4 separate areas. The first is the chessboard and the chess pieces, essentially representing the moving parts of the game. The second part is legal move detection, and this is pseudo-legal move, trying to figure out what all the possible pseudo-legal moves a particular player has on the board. The third is something called a leaf function, which I'll get into later. And the final is the game loop, tying it all together and having that full end-to-end multiplayer experience from that opening move up until checkmate or stalemate or however it ends. So starting with the board and the pieces, EU4 provides modders with a tool called a variable. You associate a specific name with a value, and you can also modify and access that value later on. Variables are not global. That is to say, variables cannot be accessed the same from everywhere. EU4 also has a concept called scopes, which are countries or provinces, and every scope has its own definition of a variable. So in order to use global variables, we need to store variables in a country. In this case, the one that modders usually use is the rebel country, because that one doesn't go away. There's always going to be rebels. A chessboard is just 64 variables. There's one variable for each square of the chessboard. And the reason we make them variables is because the particular value associated with that variable can store a piece number. For example, in this project, the value 0 is an empty square, the value 10 is a white pawn, the value 11 is a white bishop, the value 22 is a black knight, so on and so forth. And most of my mods use a system like this. It is assigning a particular value, a particular numerical value, to a particular concept or a particular item. Using that and using mathematics to try and simulate what is really going on in the underlying representation. Another core concept that is EU4 related is something called a scripted effect. EU4 gives modders a system called effects, which are things like adding treasury to a country or firing a country event. These are the bread and butter of your regular mod. No regular mod can function without this. However, to do more complicated sequences of effects or to have a particular sequence of effects that you want to run, say, 10 times over, in order to avoid copy-pasting code, there is something called a scripted effect where you put all of the effects that you want to run in one place, and then when EU4 is loading the game, it just copy-pastes that entire sequence there. For those of you that are more code-oriented, this is not a function call. This is just copy-paste, and it has certain advantages and disadvantages for that. One of the main advantages, though, is a scripted effect can be passed parameters. This is a fixed value that gets copy-pasted with the scripted effect and is something that is used extensively. You can see in the first code snippet an example of a scripted effect on the very top with a bunch of effects below it. Those use in dollar signs where you see dollar signs SRC and dollar signs DEST. Those are the parameters, and those can be provided in. On the right, you can see a scripted effect that then at the bottom calls another scripted effect. And as you can notice, the second scripted effect is called with parameter values that are also in dollar signs. And this is a very useful trick. Passing parameters all the way down the chain, it lets you do extremely complicated logic in what is otherwise a very limiting system. Now that those core concepts are out of the way, we can start with the actual implementation side of things. So the first thing is a board space, a set of 64 variables that represent a particular game board. Implementing chess like this, we can't just have one game board, because when the AI has to evaluate a particular position, we don't want to overwrite what our actual game looks like in order for the AI to do that evaluation. That is very dangerous and will lead to a lot of bugs if we don't store it properly. It's much easier to simply make every scripted effect that we have work with any board state. So what is a board state? In this case, it would be a set of 64 variables named something like core underscore A1, core underscore A2, core underscore H6, so on and so forth. And if we replace that core string with like temp underscore A1, temp underscore A2, so on and so forth, we will be able to execute any scripted effect for any board state variable and make that completely agnostic to what we're doing. And this gives us a lot more freedom with how we implement our code. Now that that is done, we can move on to the meat of EU4 chess, which is legal move detection. Essentially everything in chess and in EU4 chess uses legal moves to figure out what is going on. What is the goal here? The goal is to create a function that steps into every single pseudo-legal move and then does something. Pseudo-legal, like I mentioned earlier, is just easier from an implementation standpoint. This code could work just fine if you directly use legal moves instead of pseudo-legal moves. However, the files that write this code would be significantly longer for very little benefit. It would also negatively impact loading times. So there's a lot of reasons why we have to do this extra step of making it a pseudo-legal move and then checking if it's checked later on. If you can look at the code below, you can notice that this is a very complicated scripted effect that has a lot of parameters being passed to it, a lot of which are also parameters from a previous scripted effect. All of this is necessary information, though I won't get into the exact specifics of why we need every variable here. It is very important that the scripted effect has all of this data, which also then makes it extremely complicated to implement. But how does it work? The general gist of it is we start with a square. We don't start with a specific piece, but instead a square, which is stored as an X and Y coordinate, in this case, a file and a rank. And we want to examine every single possible pseudo-legal move from that particular square. So if there's no piece on that square, or if it's an enemy piece, there are no moves. However, if it's our piece, we can use those values to try and figure out all the possible places that that particular piece can go. Here is an example, which is the knight. The knight moves 2 squares in one direction and then 1 square in the other direction. So we take the starting square's file and rank, which are the X and the Y, and because it's 2 in one direction and 1 in the other, we have plus or minus 2 on one of those and plus or minus 1 on the other, giving us a total 8 possibilities of where the knight can move, which lines up with our understanding of chess, that the knight can indeed move to 8 particular squares from any given square. However, that's not all. We then have to do a little bit of extra processing. For example, is the target square even on the chessboard in the first place? If we start at A1 and we move 2 squares down and 1 square to the left, our X and Y coordinates are going to be -1 and 0, and negative B -1 isn't a square that exists on the chessboard, as I'm sure you're very well aware. So that's a check that needs to be performed. And the other thing is we need to make sure that this square is empty or it's occupied by the enemy. If it's occupied by one of our own pieces, we can't move there. If it is legal, we then step into that particular sequence and then execute the something that I keep talking about. Here is a code snippet of one of the possible knight moves. As you can see on the top, this is checking for the black knight, and it first checks that this is indeed the black knight. Then below it, as you can see, it adds 1 to the X and 2 to the Y, and figures out, okay, is the resulting coordinates on the chessboard at all? And is the piece that we're going to either empty or it's a white piece? And then if it is, we execute the sequence below, as you can see under that leaf. I'll get to that later. Another example is the rook. The rook can move any number of squares in one direction, in this case either X or Y, or the opposite, the negative X and the negative Y. So we take the starting square, and what we want to do is we want to examine every single square on that file and that rank, because that's somewhere the rook can move, right? But it's not that simple, because chess has a concept where pieces can block the movement of other pieces. And so we can't just take every single square in that particular file and say the rook can move there. We have to go outwards in an incremental fashion and figure out if the rook is blocked and can't go any further from there. This is another programmatic concept called a loop, which just keeps going over and over and over again until you tell it to stop. In this case, we keep going in one particular direction. So this is either increasing or decreasing, either X or Y, in a repeated fashion. Then if the target square in there is empty, let's say if we're increasing X, the square directly above us, if that is empty, the move is legal and we can keep going. Now, if that square has an enemy, the move there is still legal, but we can't keep going because that enemy blocks any further movement for the rook. And if that target square has our piece, it's illegal and we can't keep going because, again, our piece blocks our own movement. And once that's done, if we can keep going, we add 1 to that X again and we check it again. And we just keep repeating this over and over and over again until we're either off the chessboard or until one of the other pieces has blocked our movement. So this is the code snippet for that. As you can see, it's significantly more complicated, and this is actually not the most complicated piece at all. The pawns, weirdly enough, are the most complicated because they've got a bunch of weird stuff that they can do. But the other thing you can notice is up top, this combines the rook and the queen into one function, and that's kind of because the queen is basically just moving like a rook and a bishop. So when we're checking where the queen can go, we can just check it as if it's a rook and then also check it as if it's a bishop. This I wanted to highlight because it's one of the minor optimizations that are everywhere in this code. Writing good code involves optimizing stuff wherever possible, especially in the EU4 code, shaving off a few milliseconds by having this combine the rook and the queen rather than doing them separately. It adds up over time. But similar to the knight, you can see that there is that loop, there is that while statement towards the middle of this code. And then that kind of runs the logic. And at the bottom, you can see that this is basically checking, increasing the X, so moving right continuously. And then at the very bottom, once again, there is that leaf. And I think it's time to get to that right now. So the leaf function is the other like sister part of the code for legal detection. Now, the name leaf function is a total misnomer. It's neither a leaf nor is it a function. But look, I need some abstractions to keep my sanity here, so we're calling it that. Leaf functions are what you do when you reach the end of a pseudo-legal move and you need to do something. Because of course, just figuring out that a move is pseudo-legal does not accomplish anything. So what we do is when we get to the end of a pseudo-legal move, we need to give it an effect that it should execute when it reaches there. What this means is that we only need to write the entire legal move detection before once. And what we can do is we can pass it a scripted effect as a parameter. And this means that whenever we call legal move detection, we can tell it what we want to do with it. And that prevents us from rewriting code. It makes our code a lot simpler and a lot easier to debug. It is a very useful tool that EU4 provides us that we use quite a bit in this mod. So as you can see, and I'm going back to the previous slide really quickly, there is towards the bottom $, capital leaf $. That is the particular way that you use to call scripted effects as passed as a parameter. What exactly is a leaf supposed to do? So, like we saw previously, the leaf is given various parameters of its own. This is all sorts of metadata, as well as, more importantly, the start and then the end coordinate of where that piece is going. So when we have a legal move, we figure out, okay, this is the particular piece that we're moving from this X and Y, and then we're sending it to this target square, which is like the end X and the end Y. And all of that goes to the leaf to do its processing. So the things that the leaf must do is, first, it must create a temporary board state for its own evaluation and then make that move. Second, it must complete the legal move chain. It must figure out that the resulting position is not check for the current player, because if it is, that move isn't really legal. And if it is check, we should just leave and stop doing anything. The third thing it needs to do is increase the count of the total number of legal moves. This count variable is very important for evaluating checkmate or stalemate. And the final one is to do whatever extra stuff that it wants to do. The counter. This is the simplest leaf function. It just increases the counter. It does not have any extra effects. This is used for checkmate or stalemate detection. That is, if every single piece on the board has 0 legal moves, the resulting position is either a draw, or if there's a check, then it is a checkmate. And this is kind of how that's implemented. So you can see at the very top that you create a temporary board state in that particular naming convention. You make a move, and then after making that move, you evaluate if the current player is in check. I use this particular variable, checkmate idiot turn, because I like to name variables rather mean things when I forget to add something into the code and then have to create some sort of rubber band fix to add it later. There is a considerable amount of this in this mod, more than I'd like to admit, but it all works, so what can you say, really? And then at the very end, it just increments the counter if it's not check at all. Another example is the highlight leaf. So when we're playing chess on the big board, squares are highlighted when you click a particular piece, and that's going to every single square that that piece can move to. How do we implement this? Use a special board state, a highlighted board state, that stores a value for 30 plus a regular piece in case it is highlighted. And the reason we use 30 is then we show that little highlight, that little green square, if the value is over 30. Yeah, so as you can see, this particular code snippet down below just examines if it's checked like above, and then once it's not checked, and this is kind of where the code snippet starts, all it does is it increments the counter and then calls another scripted effect, the highlight square, which all it does is it essentially just adds 30 to that value at that X and Y. But we've kept talking about how we detect if a particular piece is in check, and I haven't explained that at all, so let me do that now. In order to check if a board state is under check, we first need to figure out if a particular square is under attack from the enemy. This is a chess term to demonstrate that an enemy piece can move to the square and or capture the piece at the square. This is basically just working backwards from legal move detection. Instead of making a move from the target piece, we instead take that particular square and work backwards. We make a move in the direction of a particular piece, and then if that piece is found there, we're under attack. For example, if there's a bishop to like the diagonal right of this particular square, and that bishop is an enemy bishop, that square is under attack. Check is just a king being under attack. So in order to identify if a position is check, we start by finding the king on the board. We do this by checking every single square to see where the king is. And if the king is present on that square, we then determine if that square is under attack by the enemy. And if it is under attack, it is check, but if it is not under attack, we are not in check. On the player's turn, and this is going over that entire loop of going over whose turn it is, playing their move, and then going on to the next turn. We have to first make sure that the current position is not checkmate or stalemate. That is after the previous player's move. And if it is not, then we allow the player to select a piece and then highlight every single square that that piece can legally go to. Now, we only allow the player to select a highlighted square from here on. When they do, we move the piece in question to that square. We already know it's legal because we highlighted that square previously, and so we can skip checking if it's legal again. And then at the end, we skip to the next player. All of this, as mentioned, is handled through a bunch of hidden events, as well as a little bit on the province UI, but there are a ton of events that fire to make this work. Here, for example, is the event that drives a player actually making a move. Won't get too much in depth into it, but this is just providing a little example. So now we have one player's turn of chess working. How do we switch to the other player? What we do is we store both players in an event target. And an event target is kind of like a variable, except instead of storing a value, it stores a country. You can store which player is white, which player is black into two separate event targets. And this lets us use a variable to store whose turn it currently is, and then the two of those together can be used to determine who gets the event for the next turn. And then that lets us basically create this whole game loop of switching between 0 and 1 for the current turn over and over and over again until the game is over. And there you go. You've got multiplayer chess. So moving on to the next component. But before we do, I'll pass it over to Lemon to see if he has any questions.
Well, I guess we'll start with the big one. Are you okay?
September 2023. I fell 30 feet down a waterfall and broke my skull. And ever since then, I've been addicted to EU4 modding.
Well, I kind of want to start with the optimization point because you talked a little bit about that with how the rook and the bishop kind of combine into a budget queen, as it were. One of the things I've also really noticed, especially while actually playing chess with an EU4, is that it's either working absolutely flawlessly and not lagging at all, or it just has a big massive lag spike and then it's all fine. Like, how much of a difference would you actually say all the total optimization steps you did made as a difference for the final product?
This particular optimization would have had a fairly minimal output. However, all the optimizations in general took this from not really particularly performing too well to performing quite fast. And the metric for this actually isn't the in-game optimization. There's not much that can be done about the in-game optimization, but more specifically examining loading times. That is where the big change has happened because my original implementation versus my optimized implementation have a big difference. I'll get to that later, but it is not a metric of seconds or minutes. It is a matter of years that have been shaved off in time. Assuming my napkin math is correct, because I obviously was not waiting for years to make sure that the game loaded in the time that I'm saying it does. But
Makes sense. I'll be a bit worried if you manage to just spent 2 years trying to check if the game loaded during a 2 week modathon. I feel like that's definitely some kind of temporal cheating going on in that case. But I will have to say as well, like for the actual implementation of the chessboard and pieces, isn't there, and it's going to sound like from a layman's point of view, but isn't there a better way of checking if you're in check than like you basically go through the entire chessboard to detect where the king is, but wouldn't it be just easier to go look at the king, look at variable whatever you assign to the king? I'm assuming like variable 7 or variable 27 for the black king, and just go, where is 27 at right now, instead of going through every single square and checking, is 27 on the square?
That is another way to implement it, storing the king in a particular variable and storing like the location of the king and referring to that. And yes, you would be right, that does shave off time in figuring out if a particular position is in check or not. However, that makes the AI code significantly more difficult to implement and also significantly slower. I am not sure I can get into exactly why without being like a code nerd for like 20 minutes, but there is a good reason why a lot of this stuff is implemented the way it is, and why there is that linear time examination of where the king is.
Makes sense. I will have to again say though, with the move highlights, the distinction of you can only move a piece to where a move is highlighted, and then just because the like possible move is already highlighted, we don't have to check if it's a legal move. That's actually quite smart. Like it's kind of a weird optimization never even considered. But will there be any other like these kind of small optimizations you wouldn't think about that kind of happen almost like, yeah, we don't actually need to check if a move is legal if it's already highlighted kind of assumptions?
I think one similar optimization is when checking checkmate or not in checkmate. A lot of the AI calculation when you're playing a game against the AI uses legal moves. And so we can skip that typical checkmate checking for the player and use a lot of that AI code there. But other than that, there's no real like obvious optimizations. A lot of it is just very minor stuff scattered throughout. There is one very major optimization, but I'll get to that with the AI section.
With that said, shall we get into the AI section then?
Yep, we shall. So starting out with the general concept of a chess engine. A chess engine is a computer program that can play chess. But anything can play chess. A 2-year-old can play chess if you teach it what a legal move is. The thing that a chess engine needs to be able to do is it needs to be able to play a move that is actually good. We don't just want it to play a random move like a 2-year-old would. And as I'm sure Lemon remembers from earlier iterations of this particular chess engine when I was still working on it, it did actually play very much like a 2-year-old. It would move its rooks, it would move its pawns out from the H and the A file and then take the rooks out to the center of the board. But it takes a lot of work to make a chess engine, and the core of that is the idea that it has to be able to assign a numeric score to every possible legal move that it can play, and then it has to play the move with the best score. And that is how you mathematically take a chess position and figure out what move to make. And that is also how chess engines and stuff like Stockfish or similar work. Though, of course, their score function is a lot more complicated than my score function. My score function here uses 2 parts. The first part is a p-square table, and the second part is minimax. I'll get into both in detail. Starting with the p-square table, a p-square table or a PST takes a chessboard and evaluates it into a numerical score. And this is done by having a score for every single piece in every single possible square that that piece can be in. Of course, some pieces are just intrinsically worth more than others, but also some pieces in some squares are worth more than others. For example, a white pawn on the 7th rank is going to be way more valuable than a white pawn on the 3rd rank because that pawn is about to promote. So the AI evaluates every single possible legal move it can make. It takes the PST score at that target move, and then it wants to play the move that results in the best PST score. It results in the best position for that particular AI. Down below in the code snippets, you can see some of that. So the chess evaluate position takes a board state variable set of those 64 squares, and then it assigns it a numeric score. The score is positive for white and negative for black. And as you can see, that score itself calls other functions, calls other scripted effects. In this case, that is a chess score effect underscore A1, which is just saying, what is the current value of A1? given the piece that is present there. And then that scripted effect itself is shown on the right. It basically fetches the piece that is present there and then figures out how much it's worth on that square with a bunch of hard-coded values based on a piece score table. This is not something that's calculated in-game. The scores for a particular piece in a position are known and are tuned by me on my own. And tuned by me on my own, I of course mean stolen from the internet. So the PST is enough for a basic AI on its own. All we do is we create a leaf function that takes the resulting board state from making a particular pseudo-legal move and gives that a score. So all we have to do is detect legal moves from every single square on the current board, score each of those legal moves, and then just have the AI play whichever one is the best. But that's not very good, because that just looks at what the AI does. It does not look at what the player's response is. So how do we fix that? Well, the first thing we can do is we can assume that the player is always going to play the best move. Now, for the AI to figure out what the player's best move is, all we do is we have the AI ideally play against itself. And that's how stuff like Stockfish works. It evaluates what it thinks is the best move for the player to play. So how do we do this kind of an evaluation? How do we make a move and then have the AI decide, okay, you've made this move as the black AI, now the white AI has to figure out what the best move here is as well. And then we keep going down and down and down over and over and over again. And the answer is an algorithm called Minimax. I'm not going to explain Minimax search here. It is a fairly complex algorithm. I would highly recommend checking out a tutorial on YouTube if you are interested in learning more. I'm just going to cover the implementation here. The main problem with the implementation of a Minimax is the idea of recursion, which is central to Minimax. Because Minimax essentially calls itself over and over again. Like I was saying, the AI calls itself over and over and over again to try and figure out what the best move in a position is, and then what the best move for the other person in that position is, and keep going down and down and down. But EU4 scripted effects are not function calls. Like I mentioned, they're just copy paste. This means that a scripted effect inside itself is just going to crash the code as it keeps copying and copying and copying and copying and copying over and over again until EU4 runs out of RAM and crashes. So the naive solution to this is just, why not just copy paste the scripted effect content? Like I have Minimax depth 1 as one scripted effect, depth 2 as another scripted effect. And if I'm going all the way down to like depth 8, it would just go 1, 2, 3, 4, 5, 6, 7, 8, and then stop at 8. That works in theory, but it's still copy paste, and that means that the code size increases exponentially. So copy pasting legal move detection inside itself is a problem because this is a 2500 line of code function, and 2500 to the power of 4, which is as deep as this AI goes, is quite a bit larger than your computer can reasonably store in its RAM. What this leads to is, like, okay, if we do a minimax depth of 2, our loading time can be measured in hours. If we go to depth 3, our loading time suddenly is now measured in years. You go to depth 4, I don't want to think about it, but it is pretty bad. And of course, that's just looking at the legal move detection function. The napkin math that I did to get this time looks at every single thing that this has to run, getting a rough estimate of how much code that is and how much time that's going to take. This is probably the biggest optimization of this code. It uses events to try and simulate and solve this problem. How do I do this? Events in EU4 code have an immediate section, which is effects that are executed immediately. Calling an event is just one line of code, but that one line of code can then go through and in a separate area call the whole legal move detection again, and this prevents us from having the copy paste problem. Now, because EU4 isn't really particularly parallel, this means that the immediate effect is executed immediately, and then once the immediate effect is done, it goes on to execute the rest of the code. And the upshot of this is it's functionally the same as if I just did more copy-paste scripted effects, but it's significantly less intensive on loading times. However, that is a trade-off because now we no longer have loading times of years, but instead we're now executing 27,000 events for Minimax Depth 4. So remember, Lumben, when you mentioned that sometimes the chess AI takes a lot longer to execute than at other times? This is because in some situations, the number of legal moves is a lot more than in others. And even though these events are hidden events and the player doesn't need to click on this manually, in order to make the event pass, because making someone do that 27,000 times to make chess work would not be a great idea for a modder. Even still, it is very slow, and it also has a few EU4 related issues where sometimes every now and then an event just doesn't fire properly. And so this means that the AI every now and then, because of some random EU4 bug, will miss a move here or there, which completely breaks most ways of optimizing minimax, such as, for example, alpha beta pruning, which is a classic. I can't get into why because that is a lot of math, but trust me on that. This, for example, is the event for minimax depth 3. As you can see, it basically just calls this all legal moves function, which takes every single legal move on a given position. And the leaf in this particular case is chess minimizer 4, which is a scripted effect that runs the next minimax step. So each minimax step has a particular event associated with it, as well as a particular scripted effect, and this makes code a lot more modular and a lot easier to handle from an implementation standpoint, and then also fixes that whole recursion issue. So Minimax itself, what it does is it alternates between maximizer and minimizer layers. The AI always maximizes and the player always minimizes. And like I mentioned, I'm not going to go over what that means. Please watch a tutorial if you want to learn more. However, at each minimax step, we have to build what's called a minimax tree. Instead of doing that, we use various optimizations, but in theory, for each step, we have to step into the legal move to build the minimax tree. We don't actually build a tree here, but it is a good abstraction to keep in mind. And at the leaf of each minimax tree, and this is why I named those functions leaves, because of this particular setup. At the leaf of the minimax tree, instead of going deeper, what we do is we use a special leaf function that evaluates the score using that p-square table that we got before. And then we work backwards up the tree to find the best move that the AI can play. And what this accomplishes at the end of the day is, like, if black is the AI playing here, we have black play a move, white plays a move, black plays a move, white plays a move, and then we get the score. And we want to figure out what black move that black plays initially would result in the highest possible score, assuming then that white gets to play again, and then black gets to play again, and the white gets to play again. So it gets quite in depth. One other thing to note here is that any sort of checkmate is always scored at like plus or minus 100,000, which is bigger than the p-square table can ever return. And this is made sure so that the AI never misses like a mate in 2 or something. Yeah, all it cost was my sanity. The AI can now look at any position and identify the best move that it thinks it can play for both white and black. In the game loop function, all we have to do now is, if the game is against the AI, instead of having that second player have to click a piece and then highlight it, we just calculate the best move and just have it play. And we're going to know that, of course, the best move that the AI makes is obviously a legal move, because the AI uses legal move detection so much. We don't need to check that for them either. As you can see down below, and put special focus on the line number, because this is the length of some of these files that make the AI work. There are some rather large files here, like especially in the center, that almost 60,000 line of code file. This was quite intensive to make. One other part of the AI is book moves, opening preparation. Obviously, Stockfish is going to be better than this AI. This AI is written and fully executed in EU4 code, is actually fairly decent and has managed to beat a bunch of people, which I'm surprised by, but it is not a particularly amazing AI. But we can give it a bit of a head start. How we give it a head start, we have Stockfish figure out what the most common openings are and what the best move in those openings are. Then just store that in EU4 code. And so when we start the AI evaluation, we just check if a particular move is in our opening database. And if it is, if a particular position is in our opening database, we know what move to play for each particular player. Now, this is a lot of code that gets executed at the start, but we don't want to execute these 600,000 lines of code all the time. And so we have this done specifically for the first like 6 turns, the first 3 moves that are played by each player. And then after that, we just kind of skip this entire section. And as you can see, this file is so big that syntax highlighting no longer works. This makes debugging code really easy and not a pain at all, and has caused absolutely no issues for me. A few miscellaneous things to note with the entire chess code part. So there's castling and there's en passant. For castling, we need to store if the king or the rook that is currently castling has moved. And for en passant, we need to store if the last move was a double pawn move and in what particular rank that pawn did a double move. Minimax, we can't just use the global variables that store this information. Each level in the minimax tree needs to know this data from the previous minimax level. For example, if I, as an AI, am evaluating moving my pawn 2 moves ahead, I need to then pass that information to the white AI that moves after me, because then that white AI might be able to en passant me. If I'm unable to make that calculation, my AI is just not going to be very good. And so a lot of these leaf functions need to be passed a ton of variables. Most of the leaf functions don't use these variables, but they are important for Minimax specifically. Another thing to keep in mind is variable overriding itself. EU4 scopes are not the same as programmatic scopes. Variables are not localized to a particular scripted effect, they're localized to the country. This means that if I use the same variable name in Minimax Depth 1 and in Depth 2, the Depth 2 code is going to overwrite my Depth 1 code and break everything. So every scripted effect needs to have its own set of variables that it can edit, and that needs to be provided to it in the leaf function. A good example here is the code snippet provided below for the isWhite check function. For that particular function, a whole bunch of variables specifically related to HL_L, which is my highlight leaf effect, are provided to that particular function, and that makes sure that when you're running this for highlight, you aren't overriding, for example, what the AI is doing when it needs to check if white is under check. This leads to some truly incomprehensible variable names to anyone that is reading this code. Trust me, it's better this way than having it write out like 30 different words connected with underscores like your average Java code. Another thing, how can one person write 500,000 lines of code in 2 weeks? No, I did not write this by hand. I don't have quite that much free time. In fact, I would go so far as to say I don't have quite that much time, even if I didn't sleep and didn't go to work. I don't think there's that much time in 2 weeks. However, EU4 code is pretty replicable, and there is a lot of automation that you can do in other programming languages that you can't do in EU4. But instead, what you can do is you can use Python to just write EU4 code to do a bunch of different stuff. And this also solves the problem of scripted effects being unable to use variable values as their arguments. And that is particularly important for, oh, I'm given a particular variable that stores X and a variable that stores Y. I can't, by default, use that X and the Y to carry out an effect on the X and Y square of a board state. But I can use some Python code make it, basically look like did that. And for those of you that are interested, this basically takes what would be in any other programming language, a constant time operation. It's just logarithmic, so it's not too bad. You can't make it anything better than logarithmic, unfortunately, because after all, EU4 code was not written with the intention of you putting chess in it. I don't know why the devs didn't make it so, you could add chess to the game easily, but,
They're saving it for the next DLC. Like, come on, you have to think about this stuff.
Of course, they got to make money off of us modders. A final thing is testing, and Lemon, you can go on about QA, how you did stuff, because that was super important to like that final week of finding all those bugs that you did.
Hello, I helped. Again, yeah, there's a couple definitely that I found quite funny. The vassalization, like I'll talk about the actual chess implementations because the rest of it was just, wait, can I vassalize the chess AI and stuff? But for example, the chess AI at one point, like in one of the openings, there was a position where I had a pawn on the d file and I had a pawn on d4 and a pawn on d5, and black took my pawn on d5. But if for some reason I activated the en passant code, so it basically managed to take two of my pawns with one pawn. At least that's my thinking. I activated the en passant code. I'll let Sol elaborate if that was the case. There was a whole bunch of QA stuff like that. Like at one point, the Black King, when I was trying to see if I can get him to a stalemate, decided to avoid stalemate because he actually had two moves. One would lead to a stalemate, and the other move would lead to... Well, he had one move he could actually do, which would lead to a full stalemate next move, but White managed to avoid that situation because I was playing us back in that position by capturing his own piece. So that was a fun bug as well. The integration and vassalization of the chess AI, I think, is a Sol just hating me because I would have loved to post a chess AI one-tag world conquest, but apparently I'm not allowed to do that. Basically, it involved the fact that despite the chess AI capital having an infinite distance away from your capital, if you could obtain a way to core without limit, so for example the monument in the Aztec land, or just the age ability in the final age of the game, you're able to dip annex the chess AI and you're able to vassalize these things, because turns out the chess AI had a bunch of code on it that basically prevented it ever having money or troops. And this wasn't actually mentioned in this presentation, but basically meant the chess like AI that was controlling all these variables that were assigned to it was super weak. And so if you just kind of said hi to it, it would be like, yeah, sure, I will be your friend. And then it had no development because he had zero development of all the provinces because they're meant to be glorified wasteland provinces. So just become vassalized and become your subject, so you could give it a core. That meant that you could then dip annex and release some players and do all those other fun things. And I was able to get that in playtesting. Unfortunately, that's all been fixed now. So maybe you can do a chess world conquest, but to the best of my knowledge, you can't, and that's because Sol hates fun and doesn't want to let me do a chess world conquest.
All right, with that insightful explanation of the QA involved in this mod, which was mind bending. Some of these bugs like absolutely threw us for a loop. There's one really fun one where Lemon managed to offer a draw to the chess AI and then received the offer for draw by himself.
Yes, I did.
Reason,
I'm not sure I managed that yet. Yeah, there was a part where if you're ever losing. Yeah, I'm not sure that's ever was fixed, and I don't think I could replicate it as well. But indeed, there is a situation if you're ever losing, you can offer a draw and then just accept it before the message comes to the AI, and therefore you can never actually lose against the AI. Because if you're losing, just offer a draw.
That was fixed. You can no longer even offer a draw to the AI.
Ah, there we go. We've now fixed that.
But it was fixed by making it impossible to occur. The bug, nobody knows what happened. But doubtless there's still bugs involved in this mod.
I'm sure someone would love to give a shot debugging this.
Yeah, I'm sure someone would have a lot of fun trying to figure out how these bugs are happening. But that's not going to be me. I've done enough debugging for this one. Moving on to the next two parts of this mod. Both of these are done by other teammates. 3D models are done by Scrub, and then the province UI, the art for that was done by Zorm. Yes, that's the same guy who made that AI mod that everyone uses. Starting out with the 3D models, and then also like the art and stuff. How do you make these? I don't know, man. I'm a programmer. I've never had to do anything like this. God forbid I ever have to. Scrub had spent 55 hours in Blender over the course of this project to make all of the 3D models. From an in-game point of view, EU4 has an inbuilt graphics renderer. This allows you to do things called ambient objects, which are just a 3D model that you put in the game, and you can make your own ones using 3D models, like using Blender or Maya or something. What I do is for every single piece in every single possible square, I make an ambient object for that piece's location, and then I only just show the ones that are actually there in play. This also means that I can limit the themes really easily, so if the player is using a particular theme, I just hide all the pieces for one theme, and then show all the pieces for the other theme. And so from my point of view, from like the programmatic standpoint, super easy. Huge ambient object file, but it's all written in Python. From the point of view of the guy making these models, literal insanity.
And this is coming from the person that added the chess game engine into EU4. So you know when he says it's insane, it's insane.
And then, yeah, moving on to the province UI, EU4 has custom GUI support, but somebody still has to make the art for that custom UI. And you'll see this when you click on a particular piece, the little thing that pops up in the top left. That's just a province UI that's hidden with like our own UI on top of that. And what that's basically doing is it allows us to add our own two buttons. The art for that particular screen with all the various things, places that the different pieces can move, as well as the art for the buttons and all that stuff, that's done by Zorm. He also made the chessboard as well as the 2D piece art. How he does that is beyond me. I'm still very much of the impression that every mod that I've done in the Modathon has only had like that winner or that runner-up spot, specifically because Zorm's art is just delightful to look at, and everyone's like, ooh, that looks cool, I want to try that out. Every single Modathon, we've either won it or been a runner-up so far, so all credit to him there. I just do code. But in this particular case, it's just using that custom GUI setup, and that chessboard is also an ambient object because you can make 2D ambient objects instead of 3D ones. The upshot of all of this is that none of it affects the base game because we didn't actually touch the province UI. We just kind of added our own stuff on top of that only affects the chess squares. So you can play a perfectly normal game of chess if by perfectly normal you don't mind the giant wasteland square in the middle of the Atlantic. So yeah, any questions on any of that, Lemon, or we can move on to like the conclusion of all of this?
I mean, I will have to say that this is again an act of pure insanity, especially for the optimizers. When it comes to the well, when you added the opening theory, So the book moves, as you refer to them, basically, or the opening books that the AI uses. This is a relatively common thing for the people who are not aware with the chess engines. Naturally, that if you put a chess engine, even the best ones today, and tell them to analyze a position from day one, they're not going to do as well as like the thousands of years of human history that we've spent like analyzing possible chess moves from day one, and even the thousands of hours of machine time machines have spent analyzing just from the opening position. So opening book theory is pretty common. But like how when it came to the actual depth of implementation, because some openings have like 19 move depth of book moves, right? Where's your cutoff point of how much is enough book moves to get the AI going, and how much is too many book moves, basically?
I just made it simple and set it at 3. Stockfish doesn't really have the Python library for Stockfish, I should say, doesn't really have a way to get like an opening database, and there's no easy to find opening database on Python, so I can't just look through and find the most popular moves. It is possible to use like the Lichess database or something to find the most popular openings and then go to a depth that is relevant to their popularity, but this was made for a 2-week project. I did not have that kind of time. It just goes to look at the first like 3 moves that either player can play, like the first 3 turns of the game, and then after that, the AI is on its own. It also doesn't cover every single set there. Like, there's no Bong Cloud code. If you play the Bong Cloud, the AI is kind of on its own from the get go. So I think that's a pretty reasonable decision there.
There's a lot of cases absolutely where if the human player is playing something absolutely unhinged, I don't think planning for the human player to open with like a knight to the edge of the board day one is a good plan, right? It just adds more code and more pain and suffering. But on that note, I mean, 500,000 lines of code is rather impressive. And I think you teased a 60,000 or is it 600,000 long document. Is that the biggest one in terms of code lines length out of everything, or is there something even more monumentally massive that you're hiding from us?
No, that is the biggest one. That is the biggest one by an order of magnitude. There are a bunch of files that have 10 to like 80,000 lines of code, including the ambient object file, which is massive. I think that one might have even reached like 100K or something. I can't remember off the top of my head, but by like a pretty good margin, that 600,000 line of code file was the biggest, and that one stores the AI evaluation as well as the book moves.
But it's quite impressive, and to be honest, for firing, as you mentioned, all of those events like off screen that the player doesn't get a pop up for, I do wonder. And I mean, you're not going to touch this again, but it would be almost a cruel like April Fool's esque joke of going back to all those 27,000 events and make them actually pop up on screen. So if you have to play the game, you have to click through each one. And again, probably a bit too harsh, but maybe as a punishment game or something would be a category to consider. But it's still like events, and it's kind of a weird mix that you've approached this. Was it more of a trial and error process of deciding I'm going to go with 20,000 events, or did you have like a plan from day one that the event system is going to be the most optimal, or storing everything in all of these ambient objects? Storing everything in all of these like pre-assigned variables is the most optimal. Like, was there a trial and error system basically, or did you have a plan from day one of how you'd approach this?
All of this code, in theory, at least to any programmer, I wouldn't say to the average person, obviously, but to any programmer, all of this sounds like, oh, this is fairly easy to implement. Why hasn't someone done it before? The answer is it's not easy, and a lot of that is from a design standpoint, but some of that is also from an implementation standpoint. A lot of the code used Python, but about 10,000 lines of code were completely handwritten by me. That also means that debugging that is a lot harder. When you handwrite code, it's much easier for you to make mistakes. And EU4 does not have good ways of logging what it's doing when it's executing code. So debugging a project like this is nearly impossible. Instead, what I have to do most of the time is just try and roughly figure out what area of code the problem is happening in, and then just read over that tens and tens and tens of times to make sure it's logically perfect. This also involved a lot of chicken scratch notes in a notebook that are completely unreadable, but it's me just stepping through my own code in my head, try and create those scenarios. And then the other thing is, of course, with debugging is when I write a particular section of code, I have to write it in a way where I can create a scenario to test it in isolation. And that adds a lot more work. There's a ton of commented code in this mod that is just a whole bunch of test stuff that is very useful for me to execute, but is entirely useless in the mod. And so I commented it at the end to reduce loading times. But going back to what you were saying in terms of how did I really lay this out and how did I come about my approach to this particular problem? This modathon has a 2-week deadline. The deadline doesn't cover planning. So I had like a 10-page document of planning that just covered my algorithms, that covered my scripted effects types, that covered what variables need to go where, all laid out in advance. Most of that is entirely incomprehensible to anyone else reading that. It is intended to be so. It's in shorthand that I understand. But it is all extremely in-depth, and all of this planning had to be done in advance. Otherwise, the mod would definitely not have been done on time. But the general thing here is that most of this uses EU4 specific things, and it requires a lot of game knowledge. And this isn't the kind of game knowledge that like Lemon has, where he knows how the game works, because I'm frankly pretty bad at EU4. This is the kind of knowledge of like how game systems work and what systems can be used for what particular areas of code. Here, I have to give a shout out to my friend Silo, who I use as tech support on every single one of these mods, because he, I would say, probably has like one of the best knowledges of how the game code works as a modder. And so I can go to him with any of these problems and just chat with him about what a possible solution is. And he would help me, maybe come up with ideas or alternatives or something like particular mechanisms or effects that can be plugged in to use in a particular scenario. And so there's not a lot of trial and error. Ideally, the whole mod is done ahead of time beforehand. It was the same for Blackjack as well, where I had the entire mod done ahead of time and then just had to code it out later on. But that, I would say, is probably the hardest part of this entire project. It's just the design standpoint of how do you design chess in EU4? What systems can you use to get this to work? Because the actual implementation of a chess engine and a chess AI is not too hard. You can do that in any programming language. But the limitations, the severe and constant and ever-present limitations of EU4 code are a problem that you does definitely require a significant degree of knowledge and planning to work out. The other thing is non-code parts of this mod also aren't easy at all, and they're also very time consuming. Scrub, like I mentioned, 55 hours in Blender making the models, insane. That's like more than a full-time job, or like basically a full-time job over the modathon period, on top of his job. Lemon did a whole bunch of province modding stuff, which like I hate map modding. It's one thing I refuse to do out of concern for my own sanity. So I don't know how he got that. Zorm has done like I've worked with him. We're kind of like a duo over this modathon stuff. I don't know how he does his art. The guy's just built different. He has a bunch of like popular EU4 mods, so he can do like the normal modding stuff. And then he's also just like an amazing artist. It's wild. I don't know how he does it. Like I say, built different. Thank you for watching my presentation. Lemon, do you have any closing statements, questions, any of that?
No, I mean, I would like to reiterate, because I feel like there's quite a few times where I tell people to not do something at home and then they go and do it at home. No, bad. Don't do this. This is a proof of divine conception of a challenge that shouldn't exist. But it is certainly a work of genuine art, and as I'm not sure you mentioned, but yes, all the links to the mod will be available in description and everything for you to go and check out. Please do enjoy the mod, give it a rating and everything. It is a work of art and just kind of an ultimate proof of concept of what's really possible in EU4. And I will have to say, is this your retirement act, or will there be something else?
Well, I am going to be starting my master's degree soon, so my time for a project like chess is probably gone. However, I definitely don't intend to retire, and especially once EU5, Project Caesar, the secret game that we don't know anything about, comes out. Assuming that it has the kind of modding capability that Imperator or CK3 does, I can do a lot wilder stuff with that than chess, and you can count on me to produce some things once that game comes out.
Well, I'm still looking forward to that, and while you probably have many thousands of hours in EU4 just from modding alone, I do have to ask, and my apologies, but do you actually play EU4? Like, the game with the Portugal and the France and the Muscovy and the Ottoman.
I do. I started playing in like middle school, I think. I've been playing ever since. I don't play it that much these days. I mostly just play Anbanar. The only thing that I've done of note is back when that Mayan Horde cheese existed, I used that to get 3 mountains. I don't really consider that an achievement because that makes it so trivially easy with like what 90 CCR or something dumb that you can just kind of sit on provinces and be really bad at the game and still do a world conquest. But other than that, I'm just bad at the game. I don't know. I'm much better programmer than I am a video game player. So
I think it just goes to show the inflation of the standards required when saying, ah, yes, I did a Mayan Horde run for a 3 mountains is considered, yeah, I'm actually not doing it properly, I don't know what I'm doing. Most people are, struggling to get the French cause back as France for that achievement. But nevertheless, an absolute pleasure for having you on, and thank you very much for this, frankly, over-the-top analysis. An absolute pleasure to enjoy, and hope to see more from you in the future.
yeah, for sure. And if anyone has any questions regarding the implementation of chess, or if they want to make something similar, feel free to reach out to me. I am on Lemon's Discord server, and I'll be more than happy to answer anything math or code related.
That is Sol again, and I guess it's an excellent time to show my Discord yet again while I'm in the process of that. So yeah, links to that will also be in the description, or just post a comment. Worst comes to worst, I'll see your comment and go past the Sol myself if it's an interesting one with that. But yeah, again, thank you very much for coming on. Appreciate you for your time as well as for even making the time for the presentation.
Thank you so much, and peace.
Right, with that all said, that is going to be all the time I have for today. Thank you very much for watching, with a special thank you to my channel members, especially Ark, Solar, W Haste, Solemon, Star72, Lord Zendikar, Nick Fassbender, Nanhatan, Nick Huss, The Awesome Rabbit, Best Pro Gaming, Grandma Flavia, Kono, Andreas Alberg, Deki, Sov, Mobkiller, Anthony35, AC Napo, Glorious Leader, Zerkis, and Mr. Kumshok.